Hi, I'm Marc Miklich, Technical Product Manager for Small Character Technologies here at Squid Inc. In today's video, we're going to discuss troubleshooting the Viscometer in your JetStream CIJ printer. All right, first just quickly discuss the operational theory of the Viscometer, why the system is using it, what it's using it for, how often it uses it, all that good stuff. So the Viscometer is on board inside the printer in the hydraulic cabinet, so we'll take a look at that in a little bit. But essentially what the Viscometer's job is to check how viscous our fluids are, the ink and makeup mixture in the mix tank. So it's basically telling us how thick or thin our ink mixture is. This is really important to maintain and manage our fluids, keep them at the correct viscosity so we can run properly and print properly. All right, so how the system uses the Viscometer to check the viscosity of our fluids is fairly straightforward. What the printer does is automatically every 3 minutes, it's doing a viscosity check. The process and how it takes that check is the Viscometer circuit, if you will, always has pressurized ink delivered to it. However, there's a valve that is closed that normally blocks flow to the Viscometer. So when we do a check, a viscosity check, we open up that valve. Okay, that's valve 1 or YV1 in the system, and we'll take a look at that later on in the video, both from a diagnostic standpoint in the programming and in the back of the machine. So again, valve 1 opens, a timer starts, and that also allows fluid to flow into the Viscometer. When we look in the back of the machine, you're going to see your Viscometer mounted in an upright position at just a slight angle. What happens is fluid goes into the bottom of the Viscometer and goes up and out the top. When that fluid enters and pushes up out the top, there's a steel ball in here that should travel up with the fluid. Okay? When valve 1 closes, this is all automatically timed, valve 1 closes, fluid is no longer being pushed through the Viscometer, and that allows the ball to start dropping down through the fluid that's trapped inside here. Okay? When that ball gets to the bottom of the Viscometer, we've got an inductive sensor coil here. The ball will enter that coil and it will stop the timer. That time value is what we use as a reference to how thick or thin our fluid is. If the fluid is very thin, naturally that ball is going to drop much faster. That'll give us a lower viscosity reading. If the fluid's very thick, it will take the ball longer to travel through the Viscometer. That will give us a higher viscosity reading. In regards to symptoms or what we might see that would give us an indication that we have a problem with the Viscometer, it's fairly straightforward. We're either going to have high viscosity or low viscosity. Okay? And to check that, we can actually go into our settings page here, and we're going to have a reference value. That's our target viscosity, and then we'll have a real-time reading. We can compare those two values. Okay, so if we go to settings, and then ink system, we'll see in the top right-hand corner, top right is our target viscosity. And again, that's really just that time value we were discussing earlier. To the left of it is our real-time reading. So with this particular printer, we're reading 54, our target is 55. That's almost perfect. General rule of thumb is if we are within 10% plus or minus of that 55, we have a good viscosity. Anything outside of that range, anything outside of 10% plus or minus, it's too far off, the system will actually give us an error or a warning saying that we do have a viscosity issue. Okay, outside of looking at our target and real-time reading viscosity, we do also have a viscosity log in the system, so we can look at kind of the history of the viscosity or which way it's trending. So if we go to maintenance, you'll see we have viscosity record, and that's going to give us a history of the viscosity value. Okay, and this goes pretty far down. So this particular printer has been pretty healthy, but again, if we have a system where the viscosity is continually climbing or continually dropping, we will see that trend in the viscosity record. Okay, another visual aid or helpful aid to help you identify what's going on with your viscometer or whether or not there's an issue is we can do a couple things with the programming. One is we can force a viscosity check. So if you want to know right away what your viscosity is, or at any time, instead of waiting for the 3-minute intervals, we can go into our settings page and then maintenance, and then we do have an option for viscosity measurement. If the system is already in the process of checking viscosity, it will tell you when you click this button. So it'll say, hey, I want to finish what I'm already doing. If it's not in the process, it'll go ahead and take a visco check when you push this. So we're going to go ahead and click that, and it'll start measuring viscosity. So this is a little bit of a shortcut. It helps speed things up as far as determining what the real-time reading is. So when it's done running this process, we should get an update for our ink viscosity reading here. We can also use this software feature in conjunction with a visual aid inside the front of the printer. So there's actually a little LED that's tied to the viscometer that we can look at when we're doing a visco check. So we'll get to that in a moment. Okay, there can be a few causes for low or high viscosity. For example, maybe the makeup cartridge isn't installed correctly, the system isn't getting any makeup to manage the fluids. We'll see the viscosity climbing higher and higher. Or maybe clean jet is being used far too often, too much makeup is getting into the system and the viscosity is dropping lower. Those are all things that can cause viscosity issues. For this video in particular, we're just looking at problems with the viscometer itself or the viscometer circuit. One other thing I'll point out really quickly here, just so you guys are aware, the real-time viscosity reading, that takes 3 minutes. Again, every 3 minutes the system is automatically checking the viscosity, but when you first start up your printer, so you start jetting, pressure stabilizes, the printer will wait 3 minutes after the system is ready before it does its first check. So when you start your printer up, for the first few minutes, don't be concerned that if there's a 0 here. Make sure it runs, again, 3-4 minutes after the system goes ready, so our ready light is on here. Let it do a check first, then we should see an update here. So again, within the first few minutes, you will see a 0 instead of a real-time reading. Okay, if we have a problem with the viscometer itself, one good indicator is the viscosity reading or an alarm status. So if the viscometer isn't able to take a check at all, if that ball is not moving inside the viscometer, what you're going to see here is a 0 always. And if you also go into your viscosity log, you will see 0 after 0 after 0 in that log. In that scenario, what that means is the ball inside the viscometer, again, is not able to move up with the fluid at all. It's stuck in that sensor coil. It's never leaving the sensor coil, so it can't do a timing check. Another potential issue with a 0 reading is the viscometer valve. So valve 1, if that's stuck and it's not opening, naturally the system can't do a check. We're also going to see a 0. The other condition we might see with the viscosity reading is an extremely high number. So if you see something 264 or over, that likely means the ball is moving up past the sensor, but then getting caught somewhere up higher in the tube. It's not able to drop back down into the sensor coil and stop the timer. Okay, so again, 0 or a very, very high value oftentimes means that that ball inside the viscometer could be getting caught. Or again, we might have some YV1 issues too. Okay, again, if we do have a really low viscosity reading, whether it's a 0 or just a really low value or an extremely high value, don't forget to use your alarm log or warning log to see some of those faults. So you'll see with this system, we had a couple viscosity faults. Viscosity is too low. Now in this scenario, we may not be dealing with an actual viscometer failure, but just to give you reference as to where you can find your faults or what they might look like, I'll close out of here really quick. So we're just on the home screen. Go to your alarm log here, and we can page through, and we can see the failure history or the alarm history as well. Okay, if we think we do have an issue with the viscometer or valve 1, we can take a peek in the back of the system here. You see where both of those items are located, and then we'll discuss how to troubleshoot each of those hardware components. All right, before we take a look at the couple of pieces of hardware that I'd like to discuss, you will notice at this time the printer is no longer jetting. It's good to have it jetting if you need to look at the real-time reading of viscosity or the viscosity log. But once you're done reviewing that data in the system, when you get to the hardware side, just make sure you shut jetting off first. So you'll see this system status here. There's no jetting, and we just have power on to the machine. All right, so we're going to go in the back of the printer. So we'll just open the back door so we can locate our viscometer, and we'll also take a peek at valve 1. So the viscometer in the JetStream is pretty easy to get at. It's actually mounted to the sidewall of the chassis here. So here's our viscometer, and all it does is it slides onto a pair of standoffs. So if we want to remove and clean or take a look at our viscometer, we'll just take these nuts off and it will slide right out. We'll also discuss the 2 hydraulic tubes and wire that are connected to it. Okay, and then valve 1, that's our viscometer valve. So easy access for that as well. Again, all you have to do is open up the back door of the printer. You'll see both of these components right away. So if we think the ball is getting stuck in the viscometer, what we're going to do is just take the viscometer out of the system and clean it out. Make sure there isn't any debris or aggressive chunk of ink or something that's blocking that ball from moving. So in order to do that, again, we need to get this off of the pair of standoffs here. So that requires 7/32 nut driver to get these nuts off. Okay, so we're just going to back those out. You will notice that there is a locking nut and or locking washer and flat washer underneath each nut, so just be mindful of those. Okay, so again, you'll see it just slid right off those 2 standoffs. You'll see this is at a little bit of an angle for reference. How this fits on those standoffs, that allows that ball to just kind of roll down the side of our tube here a little bit instead of a straight drop, which could potentially generate some chatter inside the tube. So if you're wondering why it's at a little bit of an angle, that's the reason. So now if we want to completely get the viscometer out for cleaning purposes, you'll notice we still have 3 things connected to it. We've got a wire here, then we've got 2 hydraulic lines. We need to disconnect those before we can obviously clean this out. So we'll take the wire out first. You'll see it just goes straight back to a little PCB back here. All we need to do is unplug it. Hopefully you guys can see that. Okay, so I'm just going to take that out, and our system is powered off at this time. Okay, so we're unplugged. Now what I like to do with the tubes is I actually don't disconnect them at their locations on the viscometer. My reasoning for that is I disconnect them where they connect to the manifold, and that way it's easier to get the tip of my squeeze bottle of cleaning solvent into the tubing rather than the metal barb fittings on the viscometer itself. You can take them off here if you want. Again, it's just a little bit more challenging forcing fluid in. Regardless of what way you do it, make sure you keep track of both sides. So the bottom is our input, the top is our output. If you need easier access, even for unplugging the wire or for disconnecting your hydraulic lines from the manifold, just remember this does slide out. So there will be 2 screws in the front of your drawer. Just take those out, 2 large Phillips screws. That allows you to slide your hydraulic assembly out for easier access. So again, what I like to do is disconnect the tubes from the manifold. Again, keep track of what's what. Okay, so your input and output, just make sure you label one of 2 sides. To get these off the manifold, you could use a little side cutter or pliers. Just kind of slide it right off the barb fittings. Okay, so I'll put a little pressure on this and it'll pop that tube right off. One thing to be mindful of is we obviously have some ink in here. There will be some residual fluids coming out, so it's not a bad idea to have a lint-free rag underneath here to catch that excess ink. So one thing you'll notice right off the bat with this viscometer, this one's obviously empty or cleaned out, is you'll be able to hear audibly that ball moving freely inside the viscometer. So you can hear it rolling back and forth. If you have decent lighting, you can also hold this up to the light and you'll see that ball moving back and forth inside. Okay, so that's what we're aiming for. Now again, the viscometer that you're likely working on in the field or in your shop is going to have ink in here. We're going to have some ink in the tubes. So what we want to do first is just flush this out. And again, the reason I personally like to leave the tubing on or connected is it's easier to get the tip of our cleaning bottle into the tube instead of these barb fittings on the viscometer itself. So all we're going to do right now is force some fluid, some cleaning solvent, back and forth. We're going to flush this out and try to free that ball if it is stuck inside this assembly. Okay, so all we need to clean this out is a squeeze bottle of solvent. Make sure, again, that the cleaning solvent number matches the makeup number inside the printer. Okay, so really these 4 numbers in particular are what matter. The volume is going to be different from the cartridge to your squeeze bottle. That doesn't matter as long as this number is the same. We've got the same makeup or cleaning solvent. So we've got our cleaner, and then we just need some sort of catch tray for excess fluid when we do this. So make sure whatever side the fluid will be coming out of is over that tray. And we're going to put the tip of our bottle into the other end, and we're just going to push some fluid through. So you'll see that other side, we've got makeup coming out. Okay, simple as that. And what you want to do is kind of work this back and forth in case there is an obstruction or again just some aggressive dried up ink, whatever it might be. Okay, so you just want to keep doing that back and forth until this assembly is nice and clean and clear. And again, once you do that, once it's cleaned out, hopefully you'll be able to see or notice that ball moving freely. All right, just flushing the viscometer out back and forth, 99% of the time, that's going to free up that steel ball inside, flushing everything out. That should get this working again. Technically, these can be disassembled, so these caps can be pulled off, and we would actually have access to the glass tube inside here that the ball resides in. But when you do that, when you take these caps off, you do run the risk of getting fluid around that sensor coil. So on that note, I don't know that I really recommend disassembling these for that reason, and also because these are very inexpensive parts. Okay, they're also very important. So if you're really fighting with one of these, oftentimes it's quicker just to swap it out with a brand new one. All right, once your viscometer is clean and you verify that that ball is moving freely, we can go ahead and reinstall it. And if you're not quite sure what the orientation should be, what's top, what's bottom, just remember that this sensor, the sensor coil is on the bottom. Okay, so it's a really easy visual reference to tell you which way this should go back into the printer. Okay, so we've got the viscometer slid back onto the standoffs, and again, just make sure that the sensor is at the bottom here. This will only slide on one way. So you'll see we've got the top standoff in the top right-hand corner, and the bottom standoff is in the bottom right-hand corner. And that'll also leave us at a little bit of an angle, which is what we want for that ball to just kind of roll down the side of that tube. So this is how we want it to look. Once you've got it slid back on, we don't have to put the nuts back on yet if we want to test it out, make sure everything's working properly. But naturally, we need to plug it back in, and we need to reconnect our hydraulic lines. All right, the other potential culprit, again, with viscometer reading issues or viscometer failures is Valve One. So there are a couple ways we can quickly troubleshoot this. One is through system diagnostic. So we're going to power the system on. We will not have it jetting, and we'll use the system diagnostic feature to actuate that valve and see if we can actually hear it opening and closing. All right, so if we want to quick troubleshoot Valve One through the system diagnostic to see if we can hear it opening and closing, we're going to go to Settings. We're going to go to Diagnostic, and then we're going to go to Device. And some of you may have seen this in some of our previous videos. We do need a password to access device diagnostic. That password is always the current day's date that is programmed in the system. So today's date is February 12th, 2021. So the format will be 12/02/21. 2-digit day, 2-digit month, 2-digit year. So 12/02/21, enter, and then click OK, and that'll give us access to our system diagnostic. Again, the only thing we're looking at here is Valve One. So you'll see top left-hand corner of the system diagnostic page, we have an on-off feature for Valve One. When we click on, hopefully we'll hear that valve clicking. If we don't, that's a really good indication that the plunger inside the valve is stuck. And you'll notice we get this debugging pop-up. Even with this open, we can cycle the valve on and off. And hopefully you guys can hear that Valve One clicking open and closed. All right, if Valve One is not actuating, if you can't hear it opening and closing, we'll go to the back of the machine and we'll check power to the valve, and we'll take it apart and make sure that that plunger is actually working. Okay, so again, we're looking at Valve One. First thing we're going to do is just disconnect the two wires to the valve. So again, these are crimped on fairly snug, but they should pop off if you give it enough force. Okay, one thing we can do is if you have a digital multimeter, red is your common or ground, and black is positive. You can just check that you have 24 volts here. We're not going to set a meter up and do that. I think you guys are good enough to check that on your own. But what you can do is put your leads inside each connector here, go back to your system diagnostic. So we would turn the printer back on. Again, it does not need to be jetting. We don't want it jetting. We would go to system diagnostic, actuate Valve One, and just make sure you do have 24 volts coming out at that time. Okay, if you verified you do have power here for the valve, which you very likely do, it'd be extremely uncommon that you don't. Next step is we're going to take the valve out and just take it apart, clean it out, make sure that that plunger is moving properly. So again, here's valve 1. What we want to do is get this off the manifold. So this is bolted, just 2 screws right to the manifold. So we're going to take these out to get the valve off. One thing I will point out, again, as with any of these components, there could be some residual fluid in here, some ink, so it's not a bad idea to have a lint-free cloth ready and under here to catch any of that leftover residual ink. All right, so we're just going to take the valve off. Again, valve 1. We just have these 2 screws to get the whole assembly off, so we're actually getting the valve and the solenoid. Okay, one thing to be mindful of, if you haven't taken one of these valves apart before with any CIJ printer, is there are a pair of O-rings on the back, so the input and the output of the valve. You'll notice I have one here, but the other is actually still sticking to the manifold. So just be very mindful of these O-rings. Make sure you've got them both, especially when reinstalling the valve when we're all done here. So I'm just kind of wiping the manifold off really quick. Again, we can clean that up a little bit better when we're done. I always like to especially clean off where our valve is going to get mounted back up, just so we don't get a little chunk of dried up ink or something that's not letting the valve sit flush to the manifold or anything like that. Okay, so what we really want to get at is the valve itself here. Here's our solenoid. We just want to slide this out of the solenoid so we can get at the shaft that houses the plunger assembly. So in order to do that, we just have a crescent wrench here, and we just need to take this large nut off the top. Okay, when you remove this, you'll also notice there's a locking washer underneath, so make sure you hang on to that. And then this whole assembly will slide right out. So this is what we're after. We'll just set this other hardware aside. So now we need to get inside this shaft. Again, that's where our little spring-loaded plunger is. And in order to do that, we just need to remove these 4 screws here. You do need torque driver for this. This is a T10, okay? So in order to get these screws out, you will need one of these. And again, we're just gonna back these out one by one. And one thing to be mindful of when you take this apart or when this plate comes off, there is gonna be probably some ink coming out of here as well. So just be ready for that. Again, you'll notice I'm working over a lint-free rag just in case. So we're going to set our screws aside, and we can also set this block aside here. What we're looking for when we take this apart is that this plunger is moving freely, okay? So hopefully you guys can see this, but this is spring-loaded. This needs to be able to move in and out. If we didn't hear our valve clicking, it's because of this was stuck. This plunger was stuck, okay? So again, we have to make sure that's moving freely. One thing to be mindful of when you're working on this or in this area is there is an O-ring seated in the base of this shaft assembly. It sits in there fairly snug. It's not one that's liable to pop out very easily, but just make sure that that is there when we're done troubleshooting this, cleaning it out, whatever it is we need to do. Just to give you an idea of what this plunger looks like, I'll go ahead and wash this up and we'll take it out so you can get a better visual reference. So all we really have inside of this shaft is our plunger in a spring, okay? So this spring normally sits right inside, like that. And if we put this back in, once everything's clean, again, that should move freely. So obviously if the spring isn't in here or installed incorrectly, this is not going to be pushing back like it is now. So this is what we want to see, this action. Again, if this was stuck, just make sure you clean everything up thoroughly and this is reassembled properly with the spring in place. Okay, so I'm also just cleaning off the block here. It's good when you have all this hardware out. Personally, I just like to make sure everything's clean. Again, when you do this, be very mindful of your O-rings. Just clean all of this hardware up. Okay, so we've got our valve reassembled. We can actually bolt this back onto the manifold first, then we can slide our solenoid down over the top. Okay, so again, when we put the valve back in, be mindful of those two O-rings, make sure they are in place. All right, now we can put our solenoid back on. And for visual reference, you can look at all the other solenoid valves as far as how these slide back on and where your leads or wires should go. Color scheme is the same across the board here. Red or ground is going to go on the left, and then whatever the other colored wire is will go on the right-hand side. All right, so once your valve has been cleaned out, reinstalled, we can go back into system diagnostic and make sure that we can now actuate that valve. So we've got the valve cleaned out and the viscometer cleaned out. Once that's complete, we can go ahead and fire the system back up and make sure it's checking viscosity. Okay, so we've finished our viscosity measurement and you'll see we've got an updated reading here on our display. Okay, so when we're also using the viscosity measurement tool here to kind of speed up this process, we also have a visual aid in the front of the printer. What it is there's the PCB that the viscometer actually plugs into. It has a green LED on it. And that LED that you see right here, that's on whenever that ball inside the viscometer is inside the sensor coil. So the light's on right now, it means the ball's at the bottom of the viscometer. If we do a visco check right now, so if I hit measure viscosity, we should see that light turn off, and that means that the ball is moving up with the ink that's going through the viscometer. Okay, so you'll see that light turned off, so that's a good indication, at least starting off, that this particular viscometer is working correctly. If that light does not turn off, if it's always on, it's very likely then that the ball is stuck in the base of the viscometer. Okay? So really good visual reference for you guys to use. If the light is always off, even when we think we're done measuring viscosity, that means the ball is stuck high up inside the viscometer. Okay, so the ball's never getting back to that sensor coil and activating that LED. So again, really handy visual aid to kind of tell you what's going on with the system. So make sure you take a look at this first, and that'll likely tell you if the ball is stuck or not. Okay, the last thing we'll look at here is on the actual PCB that the viscometer plugs into. If we have looked at our hardware components, so either we've cleaned out the viscometer or cleaned out YV1, and our LED condition is still the same, so maybe the light is always on or always off. There is a potentiometer on this board. And what that does is it increases or decreases the sensitivity of that sensor coil inside the viscometer. If you turn this potentiometer clockwise, it will increase sensitivity. Counterclockwise will decrease sensitivity. It's highly unlikely this is a problem. These will come calibrated from the factory, but maybe you have a system that's been in the field a long time. Sensor is just a little bit more finicky or not as sensitive. For example, we could increase the sensitivity of it here with this potentiometer. So be mindful of that as well. All right, so that wraps up our video for troubleshooting our viscometer or viscometer circuit with our JetStream CIJ printer. If you want to see more videos on the JetStream or our other products, make sure you subscribe to our YouTube channel, and also don't hesitate to visit squidinc.com for additional information on all of our products. Thank you.